The idea was to make a small educational game to illustrate the currents and the velocity of the water in the ocean. And the game is really simple. So if you throw a bottle with a message in some point in the earth, so where will it come? So it's a kind of, it's not the bottle game. Bottle game is something different. Yes, the data that I used was from the Copernicus Marine Environment Monitoring Service. And I used only static data. So, I have my notes here. So the data I used is average for one single day, and it's how good is the resolution? Oh, I think it's 1/12 of the degree. So to this precision, I have the data of the velocity vector. And well, I never worked with geodata before, so excuse me if I talk something which is appears to be nonsense. But the first challenge was to use netcdf for Python. It works. So basically, how to approach this? Well, you use numeric integration. So you have starting coordinates, you have the velocity, and then you adapt the next step. And it uses a very simple Euler method with the predictor corrector variant. It's not the naive one, but really simple. Yeah, here we read all the data. It's data about the data, metadata. So all the functions. Something, of course. So let's say we want. Well, I do a simple thing. Yeah. So we started at the point, starting point. These are the coordinates. It's located in South America. It's Punta del Este in Uruguay. And I can visualize, show you the computed path. It's, as you can read here, 20,000 steps computed. In well, actually 7,000 steps computed because it hits Earth, it hits lands before. But this is of course not very interesting to see. So we can of course start with leave that, and then actually see. No, not this one. Sorry. So you start here. Oh, it's not Punta del Este. It's or is it? Yeah, Montevideo is here, but Punta del Este is here somewhere, but it's probably not visible because of the scale. But then you see it integrates nicely and goes along the coast, and it hits somewhere in Sao Paulo. Well, I should, of course, spend time improving the algorithm and the accuracy, but instead I just thought, what interesting stuff can we do with this? And as everybody here does web services, so I wrote a small web service. Well, let's start it. So it's a small web service in Python, and the format is really, oh, you cannot see. Oh. So, send bottle, parameters are how many steps, and starting point. Well, I'm a mathematician, so for me it's x and y, the coordinates, and whether we have to apply smoothing. And yeah, so it computes it and generates. the answer is a JSON. And what can we do with this? We can, of course, write an interactive application using leaflet. So, take my mouse. This is actually useful. It connects to the talk before. I mean, if you're on a ship and you run out of fuel, then you're a big bottle. So yeah, but actually it turns out that it's not that easy to send messages in bottles because strange things happen. And but sometimes you can succeed. And well, for example, what can you do in Germany? So this spot here is Wangerooge, is an island in the north of Germany, and I just click here, and it shows me that the bottle will arrive in Denmark. Thank you. Let's go down the coast and try Den Haag.
Oh.
Oh. That's not good. Yeah, so you see the bottle will arrive somewhere here. Well, it's chances are it arrives even in Oslo. That's I think the data is not fine enough to compute here. So okay, but then a question for you: what happens if I start, say, in Norwich, in the UK? What do you think?
It goes back to UK.
Let's do it. It does the same. And even if I go to, say, Newcastle. Oh, you see, something interesting starts to happen. So the bottle will not always arrive somewhere. So, I mean, let's take Aberdeen. So it will flow somewhere in the north of Norway. But, well, I have to say, probably it will continue, but I only do maybe 10 or 20,000 steps here in this demo, because otherwise I have to program it differently, so I don't have to wait long. Well, let's do something different.
You can do also inside the Mediterranean Sea or just the ocean?
Oh, it depends on the data. I mean, I can do. So, where? Malta. Let's go Malta. Well, and but actually, I wanted to.
It's kind of like a German post.
To show. Well, where can it be actually useful? I mean, suppose we want to send messages. Yeah? So suppose you are in La Habana in Cuba, and well, now the political situation is rather good, but who knows? And if you want to send messages from La Habana, what happens then? So, there are chances that it arrives somewhere in Miami, but for sure it will go to, well, somewhere in Charleston, in the US.
What happens if you're trapped in Washington, D.C.?
You want if I drop it in Washington, D.C.? Right?
Yeah.
Okay, so, the coast in this area. Yeah, so the point is, of course, I remind you, I use static data. So it's a data from one single day. And if I would do it, the right way to do it is, of course, to use updated dynamic data, which brings me to the point of, so you guys, and the first talk was about acquiring this dynamic data, because I have downloaded one data set, but to do it properly, I have to download data sets every 10 iterations or something. But of course, I only need a small part of the data set around my point where I am. So I don't need the whole. So if the service is working in near future, I think.
So you could draw this line with terabytes, right?
Please?
You could draw this line with terabytes.
Yeah.
Some uncertainty.
I could do it, yes, yes. Actually, this algorithm uses a bit of randomization, because I also have another data set with average data averaged over 6 years, but it's in a slightly coarser resolution. But in this other data set, I also have mean errors, and I use it to randomize the steps. Otherwise, it's yeah.
Since you cannot look too much into the future, when you turn around your algorithm and basically, if you find it,
Yes, of course, yeah. I just
ask for the data of the past and see where would it have been from.
yeah. Basically, I just have to reverse the timeline, so it's
That's also data.
yeah. Yeah. So maybe one more interesting thing. So the first thing was with what I showed you was here Punta del Este. Yeah, now you can see Punta del Este.
You should make like a business out of it, because if you find a point where I need to drop a package in South America, reach Miami,
Okay, so
there's a certain kind of customer.
it's an interesting point. Yeah, so let's talk.
I can't get the connection, so you need
No.
to take care of it yourself.
Okay.
Well, this is what
So yeah, so you see, sometimes you can pass messages and sometimes not. So interesting thing happens here in New Zealand. So and you guess what happens if I drop a bottle here? Which direction? North or south? East or west?
East.
Okay, let's do it. No, it will go in the direction of Australia. So actually, if you drop bottles on some points which are small distance from each other, then you can visualize the flow lines. So it's for me, it says that the algorithm is not very wrong, because it's kind of it makes sense, and that the data is smooth and good. So it's.
If I can propose you a case. So Haley was mentioned during the presentation on Friday. This
I wasn't there on Friday. Yeah.
This plane crashing in Indonesia.
Yeah, I've been told about it. Yeah.
So did you
Yeah.
only to compare with?
So.
Just an idea. Also, I think it's really nice. You could use this to track trash in the sea and point to people where trash is going to be accumulated, so that they go there and they clean up.
Well, probably. I mean, for trash, I mean, I don't know how trash is trash attracted to another trash or not?
There's a couple of examples. The plane crash, what they had to take into account, as well as the flow of the object in water, the object sticks out. So it has two effects. One is the wind blows on it, and the other one is if the object is like a piece of wing that's got a vertical profile, it acts as a steer. So that the wind can actually then steer the object. So that gets really fun.
It's fun.
And the trash one, there was an example a few years back of somebody, it was an actual thing where lots of ducks ended up floating around with it. But you can actually now simulate that, dropping
Yeah,
lots of
very
ducks.
similar. We talked about it. There's a drift model.
Yeah.
It's done using. It's not just done using this data. It's done using similar data as well. Yeah, they did it for as a demonstration for plastic ducks, but then they also then used it to decide where would be best to put cleanups. Like you're saying about plastic. So I mean, Buoyant Slab and his Ocean Cleanup Project has these big floating
Yeah.
boom things, and they published a paper on it, and they said you should not put them there, put them in these different places. They run basically lots and lots of these simulations, like you said, and you can see where things conglomerate into large quantities. So if you've only got 5 cleanup booms, where do you put them? Really useful.
Well, I like the very slow mouth thing. Any other question?
Yeah.
And I think I missed the one important information. Which kind of products of data do you use?
I use, I've forgotten which one exactly, but it's a data of the velocity of the water from the Copernicus.
Is that the 3D of the?
It's I think.
It's 3D, right?
Yeah, I only use
Surface.
yes, surface.
Yeah.
But of course, so which this reminds me, of course, on the obligatory to-do list. So of course, the algorithm should be improved, make adaptive steps, and so on. But of course, use real dynamic data, take wind into account. But it of course depends on how easy it's to access small chunks of small pieces of data, and well, make a cool 3D visualization. I didn't think about this what you showed, but it's quite impressive. And well, I will put code on GitHub, and if anybody has interesting ideas how to actually make an interesting game out of it, you're welcome. Because well, I think about you just can send off messages, and every message will be updated, say 5 times a day, and then maybe in 5 years it will arrive somewhere, and you can pick up it using your handy because you have a geolocation handy. So it's like a Pokemon, but for messaging. So thank you.